Okay, thanks for being flexible today with my daughter being sick. So this is going to be the sets part 2 notes. If you don't already have the note packet, this is going to be, part 1 was pages 1 through 4. I gave that the other day. And pages 5 through 9 I have with me. So if you go to the module in Canvas, you can actually pull this up. And you could either write it out or print it out, whatever you want to do. You could also just write all this on paper. It really is up to you. Okay, so the first thing we want to talk about is Venn diagrams. So Venn diagrams, we've done quite a bit during this class, and they represent, kind of a set. There's a circle. There's usually 2 or maybe 3. They're overlapping. And the overlapping parts are elements that are common to all of the sets or 2 of the sets, etc. So a basic Venn diagram does illustrate the interaction of 2 or more sets of elements. And then this is just asking you to kind of create. So I want you to remember that the U-shaped, this is a union. So this means like an and or. Okay, this one here is both, like at the same time. And this one here with a C, that means not A and is in B. Okay, so there's kind of like a little bit of a caveat there. All of set B, but they can't be part of A. So let's draw those out. So the first one, just going to draw 2 little circles. This will be A, this will be B. And we're talking about it can be in all of A, which would be all of this, or it could be in all of B, which would be all of that. Okay, or it could be in both of them at the same time. This middle one here, where it has to be in both of them at the same time, I'm again going to draw 2 circles where they overlap. This is A and B. So here is A and B at the same time. So that's what this is, where they are at the same time happening. And then finally, this one over here. So we're going to draw 2 circles again. We're going to have A, we're going to have B, and now remember, we cannot have it in A, but it has to be in B. So all of the section that is B, okay, but not the part of B that is in A and not A itself. So that's what this is. All right, so now we're going to draw a Venn diagram to represent this situation right here. So what this means is it is not H and F at the same time, but it is in W completely, all right? So both of these would be an overlap like this, but we don't want that, but we do want it in A. So there's 3 letters. I need 3 circles. 1, 2, 3. Okay, so we can make this H, we can make this F, and we can make this W. Okay, so we cannot have it be in the H and the F, right? So at the same time. So it cannot be in this part right here, but it does need to be in W. So that will be all of this. Okay, so it can be the overlap of F and W, it can be the overlap of H and W, but it cannot be the overlap of H and F. So just this right there. Okay, so the next one, we need to create create an expression to represent this outlined part right here in this Venn diagram. Okay, so I want you to notice that this right here, this section, well, you've got part of H and you've got part of F. This is happening at the same time. Okay, so this is H and F only at the same time. If you were going to represent this, you would have the intersection of H and F, but we're not going to use this part here because it says and not W. So we can't use this middle section here, just this piece. All right, cardinality. Cardinality is just literally the number of items in a set. So how many, okay? So this is quantity. All right, cardinality is the number of elements in a set. So the cardinality of set A is often notated as these bars right here, or usually a little n at the front, and I usually use this one. So it says let set A equal 1, 2, 3, 4, 5, 6, and set B equal 2, 4, 6, 8. So what is the cardinality of B? Well, you literally just count how many elements. 1, 2, 3, 4. So the cardinality is 4 because there are 4 elements. All right, this one here, we want the cardinality of A and or B. So we got to think about this. Well, we've got 1, 2 is the same, 3, 4 is the same, 5, 6 is the same, and then 8. Okay, so we do need to include the 8 from here, and we need to include the 1, 3, and 5 from here when we do this. So 1, 2, 3, 4, 5, 6, and then 8. That would be 7 elements. Okay, and then this one, so this is an and or, sorry. This one here means they have to be in both of them. So this is an and situation. So in this top one here, we literally had the elements that were listed in B. In this one, we had the elements 1, 2, 3, 4, 5, 6, and then 8. That's how we got our 7. And then this one here, we want the elements that show up in A and in B at the same time. So if you'll notice, that's a 2, a 4, and a 6. 2, 4, 6. And I just, you don't have to write these out off to the side, but sometimes it's helpful. So 3 of them show up in both of them. Okay, so cardinality properties. This right here is, and or. This would be all of set A plus all of set B minus where it is in both at the same time. Okay, and here this is the complement. So this would be not in A. All right, so the complement of A, we don't want whatever A is. That means the universal set, this would be all of it, minus, whatever set you're discussing. This would be not in that set, basic subtraction. Okay, now this first property up here, it can be written it can be written differently. So this right here is both. Right? So here is an and or. You would take one set plus another set and subtract the both piece because you don't want to count things twice. Here, if you want both, you have to pick the A set, the B set, and then you have to subtract out here. This is a union. You're going to take that out. All right, so these are kind of our rules, so to speak. Okay, if at any time you're working something and these rules, like maybe you don't understand them or that you're a little confused for the moment, you can always just draw a Venn diagram, because the Venn diagram is basically explaining these rules. So here we go. The Venn diagram here shows the cardinality of each set. We're going to use this to find the cardinality of each given set. So before we get to this, let's talk about what's happening. You have 8, and this is A or B or C. So A, B, and or C, but this is not. Okay, so this is in none of them. Then we have 14 is only in C, 15 are only in B, 11 are only in A, and then you can see your overlaps right here in the middle. All right, well, we want the cardinality of A. Well, you have to think about that. You've got 11, and then 7, and then 1, and then 9. So you add all those up, and you get 28 right here are in A to some degree. With A and C at the same time. Okay, so both of them, has to be in both. You've got 9 here, and you have 1 here. So that would be 10. And then this one would be A and B at the same time, and not C. Okay, so let's think about that. A and B at the same time. You've got 7 and 1. But this 1 down here is also part of C, and I cannot use that. So I have to cover that up, and I'm left with 7. It's in A and B at the same time, but it is not part of C. Okay, that's how that works. Then we're going to start applying this to some situations. What is the cardinality of P, which is the set of English names for the months of the year? So I want you to think about it. We have January through December. So how many months is that? Well, in our calendar system, okay, that would be 12. So the cardinality would be 12 months. That's how many names that you would write on your paper. Okay, moving on. Okay, now we get to kind of some fun stuff. All right, we go and survey 200 people. So this is all of the people that were surveyed, and we ask them, what beverage do you drink in the morning? And we offer them choices. We say tea only, coffee only, or both coffee and tea at the same time. So here's our reporting, okay? 20 are only tea, 80 are only coffee, and 40 are both at the same time, okay? Now, if you add those up, you're not going to get 200. So coffee total would be 120. Tea total would be 60, but this right here, there's an overlap of 40, okay? So you have to think about that. This 120 includes the overlap, and this 60 includes the overlap. So let's think about it. You have 80, you have 40 that are both, you have 20 right here, so you have a grand total of 140 people that have answered the survey, tea, coffee, or both. Well, we surveyed 200 people, all right? So neither, so that's what we're wanting. Question 1, how many people drink tea in the morning? Okay, so we have tea in the morning. You have 20, that's only tea. You have another 40 that they drink tea and coffee. So that is a total of 60 people that drink tea in the morning. Now, as far as neither is concerned, all right, you have 200 total people that we surveyed, right? And we're going to subtract all of this because this is what was answered. So we have 140 people. They drink tea or coffee or both, which leaves 60 people total that don't drink either of those beverages. All right, next we're going to go through this one. This is 50 students. Okay, so 50 students total answered a survey about what classes they were taking. So you have social sciences, you have humanities, and you have natural sciences. Okay, so there's a total of 50. All of these letters add up to 50. So here we go. 21 were taking a social studies course. I'm just going to write 21 right here by social studies. And social studies is A plus B plus E plus D. I'm going to write that down. A plus B plus E plus D. These four letters. 26 we're taking humanities, and that would be C plus B plus E plus F. 19 we're taking a natural science class, so that would be G plus D plus E plus F. And then H over here, this would be 7. Okay, so this is H. There were none. And then we have 3 that were taken all. I'm going to put 3 right here because 3 is E. They were taking all 3 courses at the same time. Okay, 10 are taking humanities and natural sciences. So I'm going to come over here. So humanities and natural science, well, that is E plus F. Well, I already know that E is 3, which means F has to be 7, because 3 plus 7 gives me the 10. 7, we're taking social studies or social sciences and natural sciences. Well, that's going to be E plus D. And we already know that E is 3, so that means D has to be 4. 9 are taking the social sciences and the humanities at the same time. And we know that that is going to be B plus E. E is 3, and if we have a total of 9, then B would have to be a 6. So now we're going to come down here and going to answer this question. How many students are only taking a social studies course? Well, let's think about it. 21 students are taking social studies. We're going to subtract the students that are taking other courses. So I'm going to subtract the 4 plus 6 plus 3, which is basically 13, right? We know that this is 13 students. 21, take away 13 students. Okay, and let's see. Yep, I got them all. That would leave 8. So 8 is in this section right here. They are only taking social studies. All right, next we have a survey about the online services that you've used in the last month. We have Twitter, Facebook, and both. The results show 40% of those surveyed had used Twitter, 70% have used Facebook, and 20% have used both of them. How many people have used neither Twitter or Facebook? That means none. All right, well, we have percentages here and not numbers. So for the sake of argument, since percent is out of 100, let's just talk about if we had 100 people, what would that look like? Okay, so Twitter is, let's see, Twitter is 40%, and that would be 40 people out of 100. Facebook is 70%. That would be 70 people out of 100. And both is 20%. So that would be 20 people out of 100. What we're looking for is neither. Okay, so neither Facebook or Twitter. Okay, so we are going to think about this. We have Facebook and or Twitter. Okay, that would be, so this is the number of people, right? We'd have our number of people that just do Facebook. We have our number of people with Twitter. And then we have to, so this is Facebook and this is Twitter. And we would have to subtract out those that have both. So they overlap. So it's going to look like that. Okay, so this is our and. This is pretty easy because we know that 70 people have used Facebook, 40 people have used Twitter, and 20 people have used both. So that equals 90 people total have used Facebook or Twitter or both. Okay, well, obviously our answer is going to be 10, but I'm going to show you like the math behind it. So we want the number of people who did not use either of these. Okay, they didn't use Facebook or Twitter or both. So this is the complement, the not. You have to use your total, and we are going to subtract this up here. The number of people that used one or the other or both. Okay, well, we already know that that is going to be 100 minus 90, because we already know that, and that leaves you with 10. So this is the math behind it. Okay, as long as you know to add these together and subtract out the overlap, then usually you can answer pretty much any question. Okay, so here is the last of this page. Okay, a lot of reading. A survey was given asking whether they watched movies at home from Netflix, Redbox, or a video store. Okay, I don't know how many of you remember going to Blockbuster on a Friday, getting snacks and pizza and movies. That was good times, right? Okay, so 54 only use Netflix. 22 only use a video store. I'm going to circle the word only, okay, for the single place. And 55 only use Redbox. We've got some overlap here. 12 use all three. 10 have an overlap. 30 have an overlap. 17 use none of them. So use the results to determine how many people use Redbox. All right, well, let's think about that for a minute. We already know that 55 people use Redbox and use Redbox only. So that's 55. We know that 40 use Netflix and Redbox. We know that 12 use all three of them. So I have this one so far, I have this one so far, and this one so far. And then we have 10 that use a video store and Redbox. Okay, now if this is confusing, it's very easy to just draw a Venn diagram. This is what I meant earlier. Okay, so if this is Redbox, and this is the video store, and this is Netflix, I'm just going to show you here, 54 only, 22 only, 55 only, 40 use Netflix and Redbox. Okay, 12 use all three, 10 only use the video store and a red box, so that would be 10 here, and 30 only use the video store and Netflix. Okay, so that's these little onlys. If it didn't say only for these, you would have to subtract out the 12, but it says only, and so that we can place those there. Then if you add these 4 up, all of these are red box. Every single one of these, so you can add that all up. Your total is 117 people use Redbox in some fashion. Okay, next we have set B contains 89 elements, and the total number of elements in either set A or B is 153. If the sets A and B have 8 elements in common, how many elements are contained in set A? We have a couple of options. You can do a Venn diagram. You know you have 8 in common, and set B has 89. Well, you'd have to subtract out the 8. So that would be 81 for B. So this is set B, this is set A, and we know that this number here plus the 8 plus the 81, all of this has to add up to 153. Okay? We know that, let's see, let's do this. We want the number of items in either A or B. Okay, that's going to be our 153. So that is going to be the number in A plus the number in B minus the number of the overlap. Oops, this needs to be an intersection, A and B. Okay, so we know this is 153. We do not know set A. This is 89. We would subtract out our overlap. So then here, you're going to get 81. That's what we have here. Subtract it from 153, and you would get 72. Okay, so there's 2 ways you can do it. Venn diagram, where you know that all 3 of these numbers have to add up to 153. Okay, well, you could also work it like this. I encourage you to do this because you might see that online and you might not see it in a Venn diagram. Okay, Albers Elementary School has 32 teachers. Bothell Elementary has 59 teachers, and 20 teachers teach at both. Compute the total of teachers employed at Albers and Bothell combined. Well, let's think about it. The number that teach at A is 32. The number that teach at B is 59. Okay, and the number that teach at A and B at the same time is 20. So what we want is we want the total of A and or B. So that means you're going to have whatever's at A plus whatever's at B minus the intersection. Okay, or yep, A intersection B. So that's pretty easy. That's 32 plus 59, and then you have to subtract out 20. And when you do that, you get 71 teachers. Okay, you can also draw a Venn diagram. In the last several weeks, 92 days saw rain, 82 saw high winds, and in the same period, 41 saw both. How many days saw either rain or high winds? Okay, so remember, both is our intersection, and this right here is our union. So here's what I did. The number of rain was 92. The number of wind was 82. Then the number where there was both Okay, rain and, oops, I keep writing an A. Rain and W, the intersection of both of them at the same time, we know that that is 41. Okay, so now we want to know rain and or wind, all of that. So you're going to have the rain plus the wind minus the both, the overlap. Okay, so that would be 92 plus 82 minus 41, and you'll get 133. In a loan database, there are 73 loans to clients that have 13 years of business experience. We have 76 loans made to clients with a high school education, and there are 130 loans to clients with either the business experience or high school education. So we want to know how many loans were made to clients with a high school education who also had, so they had both. So this is both. Okay, that's what we're looking for. Okay, so here's what I'm going to do. I'm going to put B for business, and that would be 73. I'm going to put HS for high school, and that was 76. We know that the union of those, so business and or high school, one or the other or both, we know that that is 130 loans. So what we want to know is, what is the intersection? Okay, so we want the number that had business and high school at the same time. That's what we want to know. So you're going to have your 130. This is the overlap. So we're going to have our business plus our high school minus the overlap. This is, let's do and or. Okay, you can always abbreviate that kind of thing. So business was 73, high school was 76, and the overlap, okay, one or the other or both, that was 130. When you add these two together and you subtract 130, you're going to get 19 loans. This is for people that had business and high school at the same time. Okay? All right, we've got 4 more. Let the universal set S, so this is the huge thing all together. Everything has to add up to 105. So sets A and B are subsets. Set A contains 30. Set B contains 72. And if the total number of elements in either A or B is 78, how many are in A but not B? Okay, so let's think about that for a minute. We want the number that are in A, and they cannot be in B. Cannot be in B. We want the A and not the B. So that means we have to take, where did I put it? Oh, we have to take our 78. We're going to have the A and or B, and we want to get rid of B. So 78, we want to get rid of just B. So we have 78, and we're going to subtract 72, and we have 6 elements that are only in A. Only in A. Okay, now there's 30 total, but only 6 of them are only in A. The other 24 are in A and B at the same time. All right, this one here, in a survey of 133 pet owners, 73 said they had a dog, and 38 own a cat, and 2 have both. So that would be your intersection. How many owned neither a cat nor a dog? So let's think about that. We want the number of cat or a dog. We want the complement of that. Okay, we don't want them to have a cat or a dog. So this is the neither. Okay, that means we have to think about all of them. So cat and or a dog. And then that'd be all of them, right? And we have to subtract out the sum of, let's see, we want those that had a dog plus those that had a cat, but we've got to subtract out of that over here the dog and cat people. So I know this looks a little confusing, but basically all of them are 133, right? Over here, I have 73 that owned a dog. We had 38 that owned a cat. And I have to subtract out 2 because that's the overlap. Those are the people that had both. And when you combine this right here, you're going to get 109. So all of them, okay, minus, those that had the pets in some fashion, one or the other or both, then you're going to get 24 that don't have anything. No dogs, no cats. And again, if these get a little confusing, go draw a Venn diagram, okay? That can be very helpful. Here's another pet. Well, there's 2 more, all right? 138 pet owners, so this is the total. 70 have a dog, 60 have a cat, 33 have both a dog and a cat. So how many owned a dog but not a cat? All right, so we got to think about that. Well, we have 70 people that have a dog. Out of the 70 people that have a dog, 33 of them, not only do they have a dog, but they have a cat. So let's do Venn diagrams on these just to kind of drive that home in case you need this. 33 have both, right? So 70, right? We want how many? Well, we've got 133, right? So there are 70 people that own a dog. 33 of them have a dog and a cat. So I can't put 70 right here. But what I can say is 70 people who own dogs, 33 of them have had both. That's going to leave me with 37. So you can think of it like that because you just want to know what the question mark is. All right? And you could do the same thing with your cat. That would be, 27 over here. I'll put 2 question marks, or they only had a cat. So we could ask it either way, and in fact, the very last question does that. In a survey of 143 pet owners, 41 have dog, 72 have a cat, and of those, 14 are both, right? Dog and cat. How many owned a cat but not a dog? All right, well, kind of like up here, if I have 72 people that have a cat and 14 of them also have a dog, so this is cat and this is dog plus cat, if you do that subtraction there, you get 58 cat owners only have a cat. So that's how that works. Okay, so let's real quick. Today is Tuesday, 4/28. I should be back Thursday. That would be 4:30. So we have some options. Number one, you can wrap up everything on your own. Okay, on your own, and then we can test in class. I could do after like a little Q&A. Okay, so that's option one. Option two is we can go over part one again if needed, and part two. We can just kind of go through all of it, and then we could, just wrap up the homework and practice test, all those things. Okay, and that means I would need to open a test window. So the test window would be, let's see, I would just do 4:30 through 5/7. 5/7 is a Saturday, and if you miss it, there is no coming back from that, because our last day of class, actually I think our last day of class is the 7th. So here's the 10th, right? 8. Well, I'd have to look at a calendar. Hold, please. Let me take a look. That would be the 9th. Okay. 9th would be Saturday. The other option is this would be the last day you could take it, or we could just do it in class, as we said before, on 5/7, and then nobody takes it on Saturday. Okay, so that's an option there. Don't forget that presentations are May 5th. Okay, so what I'd like you to do is look for an email that has a survey, and I'm going to kind of put these all in a little survey, and I'm wanting you to vote on what you want to do. So I'll provide a survey with all of the options, and I will go with probably go with a simple majority. Okay. I will see you Thursday, and in the meantime, have a great evening and stay well.